In this video, we are going to discuss concept check 5.6. Question says, which combination of resistors has the highest equivalent resistance? Here you have four different combinations given, and you need to determine out of these four, which one has the highest equivalent resistance. Before we apply the rules of series and parallel circuits, let us first try to compare these combinations and see what we get. Combination A has three resistors connected in parallel, and each of these three resistors have the same value R. Combination B also has three resistors connected in parallel. The only difference is the orientation of the third resistor, but it is the same circuit as A. Three resistors in parallel, each of them has the value R. Now, how do you determine if this was connected in parallel? In any parallel circuit, the resistors are connected end to end. That means if I have two resistors like this, both the ends of the resistor will be connected together. So this is end 1, this is 2, and this is 1 and 2 for the second. They're always connected to each other. So it doesn't matter the orientation of the resistor, whether they are horizontal, vertical, or diagonal. As long as both ends of the resistors are connected to each other, this kind of combination is recognized as parallel. So A and B are the same circuit, hence their equivalent resistance will also be equal. In combination C, the first and the second resistors are connected in parallel here. They both have the same value. And the other branch has two resistors connected in series. Let's calculate the value of resistances in combination C. So I will draw them. You have a battery, and you have the first resistor R, second resistor R along the diagonal, and the third branch has two resistors. One is 1/3R, and the other one is 2/3R. Now these resistors in the third branch, they are connected in series. And how do you identify that? In a series circuit, the resistors are not connected end to end like this. They are connected one after the other. You will have the first resistor and the second resistor. One terminal is connected together, the other terminals are not. So no matter the orientation, it could be horizontal, vertical, or it could be connected like this. Only one terminal of the resistors are connected to each other. The other terminals will be connected to something else, but not to the same resistors. So this kind of combination is called a series combination. So here you can see for these two resistors, only one of their terminals are connected to each other. Each of their other terminals are connected to the other resistor, not to each other. So since they are connected in series, I will use the rule for equivalent resistance in a series circuit to find their equivalent value. Equivalent resistance of a series circuit can be calculated by adding the individual resistances of the resistors. So I will add 1/3R plus 2/3R. That will give me 3/3R, which is nothing but R. So if I simplify my circuit, if I redraw and simplify my circuit C, you get a battery, one resistor here, second along the diagonal, and the third resistor, we combine them, and it also had the value R. So if you look at C, C is similar to the circuit A and B. It has three resistors connected in parallel, and each of them have value R. So if I try to find equivalent resistance for C, it will be the same as combination A and B. Then we have the last combination D. In case of D, you have a battery, one resistor again in series combination with the other. Then you have one resistor in diagonal, and then two resistors again in series combination. Here they have a value of half R, half R, this is R, 1 by 2 R, and 1 by 2 R. So first I will try to calculate the equivalent resistance of the series branch. I will call this as branch 1 and branch 2 for the series part. Each of the resistors in the series branch has a value of half R. So when I calculate equivalent resistance for the first series branch, I get half R plus half R, which will give me R. And the second has similar resistances, so that will also give me R. So if I reconstruct this circuit, when I draw it again in the form of the equivalent circuit, I get one resistor R when you combine them, one along the diagonal, and the third resistor when you combine them. Each of them has value R. So in part D, again you get the same circuit. You have a battery and three resistors which are connected in parallel. So even though these four combinations look a little different, if you simplify the circuit, if you find the equivalent circuit, they all are the same, with one battery and three resistors connected in parallel, each of the resistor having a value R. So since they are all the same circuit, they will all have the same equivalent resistance. So my answer will be option E. Equivalent resistance is the same for all four.